Here we demonstrate what's called the lattice method of multiplication. For example, if we want to multiply 273 by 46, we write down, first of all, and let me just kind of sketch down here, or maybe up here, how we draw this lattice. We start by drawing enough squares to represent the numbers 273 and 46. And then we draw a diagonal line from lower left to upper right in each of the squares, and we get this lattice. And we're going to see how we use this. Okay? The first number over here, 4 times 2 gives us 8. And we could put a 0 here if we like. That's just plain 8. And 4 times 7 gives us 28. And 4 times 3 gives us 12. So we write those two-digit numbers, the tens digit above the diagonal, the ones digit below the diagonal. And we do the same thing for the second digit. 6 times 2 is 12. 6 times 7 is 42, and 6 times 3 is 18. Then we add the diagonals of the lattice. Every number here, which is only 8, when you do the product, corresponds to just 8 units. So the 8 here, the sum that we get on this diagonal is 8. Which, of course, means 8 times 10 to the 0. Now, all the numbers here, the 2, the 1, and the 2, this 2 represents a tens digit because it was multiplied. You know, the 4 here means a 40 times 3, and you're going to get, that means 12 tens, so you have 2 tens here. This is a tens digit of what you get when you multiply 6 by 3. And you also have a tens digit when you multiply 6 by 7, and that's 2. So we add these tens digits. 2 and 1 and 2 is 5, and that means 5 times 10 to the 1. Then the hundreds digits are going to be in this diagonal. There's 100, and 8 hundreds is 9, and 4 is 13, and 2 is 15, so that's 15 times 10 to the second. And then we have 2 and 8 and 1, which comes out of this diagonal as 11 times 10 to the third. Now when we add these numbers up, well, we could actually add the numbers up, but we're going to regroup them in order to write this number as the power of 10. We got 8 times 10 to the 0. We have 5 times 10 to the 1. Now 15 times 10 to the 2 is really 10 times 10 to the 2 plus 5 times 10 to the 2. And 11 times 10 to the 3 is 10 times 10 to the 3 plus 1 times 10 to the 3. And this is going to give us then 10 times 10 to the third, which is 10 to the fourth. So let's write that as 1 times 10 to the fourth. And then we have a 1 times 10 to the third here. 10 times 10 to the second is 10 to the third. So we're going to have a 10 to the third and a 10 to the third. That's going to give us 2 times 10 to the third. And then we have our 5 times 10 to the second plus 5 times 10 to the first plus 8 times 10 to the 0. And we now see that our number is 1, 2, 5, 5, 8, 12,558. Now this lattice method is very close to what we do if we did the multiplication by the usual algorithm. If we write 273 times 46 and multiply this out, 6 threes is 18, this gives us 43, and this is going to give us 16. and 4 times 3 is 12, 28 and 1 is 29, and 8 and 2 is 10, and we end up with 1, 2, 5, 5, 8 once more. Now this is a shortcut of the lattice method. The lattice method writes every digit, every number here represents some power of 10. First power, second power, third power, fourth power. This would represent a fifth power. I'm sorry, this is 0th power, first, second, third, and fourth powers, as we've written them here. And this really does show you what's going on with the multiplication, and if you think about it, shows you what's going on with the usual algorithm.